Hello again. This is Roger Koch Barr for the Bioelectricity course. We're in week 7, the week where we're talking about extracellular potentials, and we're in segment number 5. So if one looks at this person in our slide, we say he is paying close attention. I can guarantee you that he and all other little kids who are paying close attention will see not only the big picture, they will follow all sorts of details. It's not just little kids. If you think of sports, there are thousands of fans who are out at major events looking at the big picture. But then there are managers and other players, and they're looking at all sorts of little details. How the player positions his legs, exactly how he catches the ball or throws the ball or locates himself before doing so or runs up and down the field. They look at every one of those details very carefully. So in this segment, we're going to look at a detail of extracellular waveforms. This is a detail that can be used to advantage, but it's also a detail that is interesting to think about in terms of how it comes about. We want to consider the waveforms that occur outside the fiber, near the beginning and near the end. So we've set up our experiment in the same fashion as before, except that we took the extracellular electrode that was over here and moved it over there. We took the one that was over here and moved it over there. So now we've pushed our electrodes out to the ends. When we do that, we once again see the intracellular waveforms looking much the same as they always have. This one from the left, we see the stimulus artifact. This one from the right. The wave shape remains pretty much the same that we saw previously. However, when we look at the extracellular waveform, the waveform outside the fiber, the shape has changed in important respects. So here we have the stimulus artifact, but then the wave shape that arises from the tissue is downward for the most part. That is in the initial phase. At the end of the fiber, we have the other situation. As people say, it's mostly upright. At least in that initial deflection, followed by this rather interesting and different kind of a repolarization waveform. That is to say, when you look at these, they don't look the same as they did for the wave shape that was out in the middle. And just as a reminder, here are the wave shapes that were out in the middle. Upward and then downward, upward and then downward. A little bit more down than up. Well, significantly more down than up. Very rapid transition from one to the other. Now let's go back. They're just not the same wave shape. So we can use these waveforms as to timing, but we can also gain information by looking at the details of the wave shape as well as when it occurs. And one finds that people who are experts in interpreting waveforms in essentially every area of application do exactly that. They are paying attention to the timing. They are expecting the standard wave shape for what they're looking at, but then they're very attentive to the details of deviations from that wave shape. And when they see a waveform that is mostly downward, there, or mostly upward, here, they're thinking beginning or end of the sequence taken as a whole. So if we think about wave shape as a discriminant, we see that extracellular waveforms are a very good tool for determining the sequence of events that are happening in the tissue. Timing is, of course, the primary information that is given by the extracellular recording. When it occurs, what the time is, usually the time of the intrinsic deflection. Is it earlier or later than other events? However, the point of this segment is to say the wave shape also is useful. You have to pay attention. It's not just some wave shape from which one determines timing. You look at the wave shape and you can figure out very interesting things. However, in the mainstream, most waveforms are biphasic, and when you see the biphasic waveform, you can look at the intrinsic deflection and know that the timing of the action potential underneath corresponds more or less to that same time. Well, here's an interesting face carved into the wall. Something tells me that the lipstick on this face has been added by a more recent generation of students. But in any event, certainly is an interesting thing to see. Thank you for watching. I'll see you again in the next segment.